Good day and a very warm welcome on behalf of NTI Audio. Thank you for joining us for today's presentation. Today we will talk about evacuation and life safety systems in general, and in particular about voice alarm systems. And when we talk about voice alarm systems, keep in mind that for the verification of these systems you need a steeper option on your test instrument, because the speech intelligibility test is a mandatory part of this verification procedure. My name is Markus Becker and I'm assisted today by our product manager, Mr. Bernard Nitsch, and he will mainly take care of your questions during the presentation. The contents that we have prepared for you start with a brief look on the motivation and the goals of the verification process. We will say something about the scope, the content of this webinar, the preparations that are necessary before you start the verification procedure, then the test procedures themselves, followed by a practical presentation. We will then wrap up what we have shown to you and also provide some application hints before we end the webinar with a Q&A session. I expect that the duration of the presentation will be in the range of about half an hour. When we talk about evacuation systems, it's quite obvious that the audibility and the intelligibility of any announcement, of any alarm message must be clear, must be well audible, must be well understandable. And it has been proven in many surveys that directed alarm messages, so spoken announcement to the public what to do in the case of an emergency, are the most efficient way to get a quick response, a quick reaction by the public. I have listed here a couple of possible locations where the law and the international standards enforce a verification of the voice alarm system. So the topic, the challenge for the acoustic expert is to measure the situation, to identify potential weak points or areas where the intelligibility, for instance, is not given, is not good enough, and then to plan and to implement, and of course also to verify improvements on that public area. The whole topic of voice alarm systems is very wide, and we had to restrict ourselves to the acoustical aspects of voice alarm life safety systems. So that includes the verification of alarm messages, the quality of alarm messages that are either announced verbally or replayed from a replay device. We will take a look on the audio acoustical signal path from the emergency microphone to the loudspeaker, and we will of course also say something about the environmental impacts that play an important role here as well. There are a couple of standards. I have listed here some international and national standards regarding evacuation systems. Please consider that there are lots of local regulations as well in your market, in your country. So before you start such a verification procedure, please make yourself acquainted with the applicable standards in your location so that you are on the safe side. I have also listed the speech intelligibility standard, the IEC 60268. Regarding the test equipment, we need a signal source. We recommend the EMA Pro as a replay device, or the TalkBox, which is also a replay device, but that has the ability to replay acoustically these announcements or these test signals, and I will come back to that later. On the analyzer side, we have the XL2 with the steeper option as mentioned before, and a microphone. Please consider here that some standards or some legislations require that you use a class 1 test system. So again, make yourself acquainted with this situation and get the required test system. Then NTI Audio offers also a free Microsoft Excel template for the post-processing of recorded data, and this tool also allows you or assists you to report the measured data. Before we start the core verification procedure, we need to prepare some stuff. One of them is we recommend that you let your test equipment being calibrated once per year, just to be sure that it is working properly and precisely. And secondly, we recommend to execute a system verification of the analyzer, the XL2 with a microphone, by plugging a microphone calibrator onto the system and verifying that it is working properly. And by the way, this also would allow you to identify or possibly compensate temperature changes and the effect of these temperature changes. Now, the first step, actually, it's still kind of a preparation, is we have to know the typical or the average ambient noise level in the public area where we have to do our measurement. And that means that you have to execute this measurement during normal operation time. Let's, for instance, assume a shopping mall. So you have to execute this measurement during daytime when the shopping mall is crowded by people walking around, talking to each other, making noise. This is the noise level that we are looking for, that we have to know, that we have to put into our overall calculation of this speech intelligibility in the end. You will see that. You have to execute this measurement at several points in the location, and these points have to be representative, which means it has to be points where people can be located in case of an emergency, and they have to be relevant. The measurement itself can be done in two different ways. The more popular one is the single value measurement, the A-weighted LEQ, which is recorded for minimum 16 seconds per point in the room. And then, as said before, you need to repeat that measurement at different points. Or you can also record the spectrum of this ambient noise. In that case, the standard requires an octave resolution, and the unweighted, the LZEQ, again for minimum 16 seconds. So the first true part of the verification procedure is the leveling. And for that purpose, if you have a voice alarm system, you need a talk box that is able to replay the test signal at a defined level. And this defined level is given in a standard, and it says that the level has to have 60 dB in a distance of 1 meter. But if you imagine you have a microphone in your voice alarm system, you would not speak to this microphone in the case of emergency in a distance of 1 meter. You would get very close to it, and so for that reason you have to do the same with your talk box. And by coming closer to your microphone, for instance, in half the distance, in 50 centimeters, the level at the microphone increases, of course. Every time we cut the distance by half, the level increases by 6 dB. You can see that here. So when we get even closer, for instance, we are here at 78 dB. Well, the good news is that you're always on the right side. When you use the talk box and you position it in the typical distance, as it would be used in case of an emergency, the level will be appropriate. You don't have to adjust it. You just put the talk box where it should be, where your mouth would be in case of an emergency announcement, and you're on the right side. Then the leveling procedure itself includes that you adjust the gain of your PA system to the level, to the volume that is typical for standard operating. You replay the alarm signal, and here actually we would recommend to use the steeper test signal. Why? Because the steeper test signal represents a typical human voice, regardless of the language. It has the right frequency bandwidth, it has a very consistent, continuous level, so it's very easy to measure it. You get very stable results by using it. You can also use a spoken announcement as a test signal. However, keep in mind in that case you have some breaks, maybe you have some fluctuations in the level, so that needs to be compensated. The standard here actually requires that if you rely your measurement on a spoken announcement, you have to increase the level by 3 dB, because that would be the one for a continuous test signal as the steeper test signal. Then take the chance, please, to verify your PA system. Is there any clipping, any distortion, any audible or hum feedback that has to be eliminated, of course, because all these effects are very damaging, are very bad for the intelligibility, so you have to eliminate them here in that early stage. And then the leveling procedure includes the verification of the alarm signal level, as mentioned before, LAQ again for minimum 16 seconds, and that has to be minimum 10 dB above the average ambient noise level that we had measured before. Please keep in mind the information I'm giving you right here are kind of a basic information. There are some special cases which need special reaction, but I had to concentrate here on the standard application, and that says 10 dB, better 15 dB above the average ambient noise level. If you cannot reach that because you are in a very loud environment, you should be at least 5 dB above the maximum ambient noise level. Or, for instance, in very silent environments, there are some standards who require a minimum of 75 dB, absolute level of the alarm message, the alarm signal. Well, up to this point, you could get along with a sound level meter that can measure LAQ. So when you have an evacuation system that does not allow any voice alarm messages, that has just predefined alarm signals that are being replayed, it would be done like this. Would be done at this point, but we are talking about voice alarm systems, and they have to be verified in addition regarding the speech intelligibility. This process starts again with the measurement of the average ambient noise level, as we have already mentioned before, or you can also enter values that you have pre-recorded on the test instrument. Then you wait until the public is gone, because the steeper measurement has to be executed in the silent room, in the unoccupied room. So you set up your test system. For instance, you connect your EMMA Pro to the input line of your voice alarm system, or you have, if you have an emergency microphone, you put your talk box in front of it, as mentioned before. And now that is very important. You have to disable any signal processing device in the signal path that has a dynamic characteristic or a nonlinear characteristic. For instance, if you have a limiter at this point, then you have to disable it so that the signal from the microphone or from that replay device goes through here without any amendment. And the reason is that if you would have an active dynamic sound processing here, that would compromise the characteristic of the steeper test signal, and that would definitely falsify the steeper measurement result, and that you have to avoid, of course. You have to have a correct measurement result. For that reason, you must feed the steeper test signal uncompromised through the signal path, and for that reason, you have to disable these dynamic sound processing devices. Next step is to execute the steeper measurement in the unoccupied room, as mentioned before, and again, and representative and relevant positions. And last but not least, you have to combine the test results from the ambient noise measurement and of the steeper measurement to the overall STI result. This procedure is, and this calculation that stands behind, is also defined in the standard. And the good news is, for instance, the XL2 does these two steps just in one. So when you are on that site, you execute a steeper measurement, you have your ambient noise level already saved on the instrument, it will show you directly the correct overall result. And I will show you that in my practical presentation. Very important to be considered, by the way, when we talk about steeper test signal, you have to use the NTI audio steeper test signal when you use our test instrument, because this test signal and the analyzer are combined to each other. You cannot use the steeper test signal from another supplier. It has to be the NTI audio test signal. Well, we are at the point of our practical presentation. I have here a very simple setup. I'm using the TalkBox directly as my PA system, as my voice alarm system, and I'm measuring with an XL2 that is connected via USB to this PC. So you will see the screen content of my XL2 in a minute, and I'm using for that purpose the XL2 projector software, which is, by the way, available free of charge from NTI Audio. So this is the content of my screen, and my first step will be now here in the sound level meter mode to measure background noise. And for that purpose, I have a Brabble noise file that I'm replaying through my TalkBox. This is a synthetic signal that emulates a typical environment where people are talking to each other and making some typical noise. So I've been measuring for 16 seconds. You can see that down here the counter has stopped at 16 seconds. I have measured an average LAQ of 72.3, let's say 72 dB. So this is my reference value for the next step, the verification whether this alarm signal level is loud enough, is at least 10 dB higher than this 72 dB. So for that purpose, I have, of course, to use a different signal here on my setup, and that is the steeper test signal. I've stopped the measurement a little bit too late, but you can see we are here at 86 dB. So apparently we have a difference of more than 10 dB between our ambient noise, 72 to 86. So there's clearly a good situation. We have a high enough alarm signal level. So this would be the very simple verification of the difference between alarm signal and background noise. Now let's go to the next step, and that is the steeper verification, the speech intelligibility. And here I want to show you this feature that I have mentioned to you, where I can directly watch the combined result of ambient noise plus steeper measurement corrected. And for that purpose, I have activated this screen that's in the steeper measurement mode. By pressing the Pages button, you're ending up in this screen. You see I have activated the ambient noise correction, and now I have different ways of loading, of getting this ambient noise. One would be, and that is what I'm going to show you right now, I measure it. I will redo my measurement once again, this time a little bit shorter, just 10 seconds. And yeah, let's start with this. So I'm replaying my Brabble noise. So you see down here the result, 72 dB, which is the same as I have measured before in the sound level meter mode. So that is my background noise level. Alternatively, I could load a previously recorded background noise level, or also a new feature, I can edit it. I can manually edit these values here. And the background here is that there are some new standards coming up that have some suggestions. They say the typical background noise, for instance, in a shopping mall is like that, or in a sports stadium it's like that. So you can use these values, these recommended values from the standard, to enter them manually into your device. Well, I'm switching to the steeper screen, and I'm repeating my measurement of before now. The steeper, I'm now testing the steeper level, and you will see the combined result in a minute. The duration of the steeper test is standardized, and you see now here the result. 0.8 is the STI result of the combination. So here we have the background noise added to the overall result. Down here you would see the raw steeper measurement from the empty room without a background noise consideration, but this is the value we are interested in because that is the one you have to put into your report. Furthermore, you see down here the LAAQ measurement in addition, 85 or 86 that we had before. So this is again the confirmation we are more than 10 dB higher than our ambient noise level. Furthermore, again by switching the Pages button, you can get some additional information. For instance, here you see the modulation indices of our steeper measurement in the corresponding speech bands. What is important here, this tick symbol shows you that the measurements in all these bands have been executed correctly, so you're on the safe side. Or on the next screen here, that would allow you to add more cycles. So you possibly, and I will come back to that later, you don't want only to measure one measure, don't want to execute just one measurement on one position, but maybe more measurements, or you want to average several positions in a room. And you can do that through this screen. You would just here click on the add cycle, and then the test instrument automatically starts the next steeper measurement. You will see them here listed up, and you will see the average. I'm not doing it right now to save some time, but you can imagine it's a very simple procedure just to record several cycles and calculate the average of the results. Now I would like to take a look at the Microsoft Excel template. This is a new version that is being published very soon. We have implemented here different languages that you can select, and the process of importing the data to that sheet is very simple. You just click here on Add Files. You select a previously recorded and saved file. The software gives you the feedback. One steeper measurement position, one noise file have been added, and here you see the file names and the corresponding data that have been imported from these files. Down here you see the overall results, so the combination of the steeper test with the ambient noise. These are other data, that's not the one that I just showed you in my practical presentation, but you can see here, for instance, also on the next screen, I have here, for instance, 3 cycles recorded for my steeper result. Here you can see the noise data in detail, or here the overall report. Let me show you one more feature. For instance, I can add another position, I can add another measurement to that file. So you see here, it's again the confirmation has been imported, and now you see here that was my first measurement position, that is the second measurement position with the corresponding results, and here on the front sheet you see again these detailed results, and that is the overall, that is the combination of the ones that I have here imported. So very comfortable, very helpful tool. You can customize it, you can enter your location name, your company name, whatever information you want to add, and then print out this report on paper as a documentation, as verification of your work. Let me get back to our presentation and summarize the procedure that I have shown to you. We started with the verification of the test equipment. We measured the average ambient noise level of the occupied room. We installed our TalkBox, or at least the replay device, and started the leveling procedure to adjust the gain. Then we measured the absolute alarm signal level and verified whether it is relatively high enough compared to our ambient noise level. And finally, we executed the speech intelligibility, the steeper measurement in the unoccupied room. And with these data, we can now execute our result analysis, the combination of ambient noise and steeper result, and if necessary, we can define whether we need some countermeasures. And I will say something about that just in a minute. What is very important, microphone position has to be located at the typical height of the heads of the people who are present in that room. So in a theater where people are sitting, it is in a lower position than in a shopping mall where most people are standing most probably. The measurement points, as mentioned before, have to be representative and there has to be a relevant number. And the steeper test needs a perfectly silent environment, no disturbing sound, because that would compromise our result. And we have to average these measurements with different positions per room. So when you are in a congress center where there are several rooms that can be used, you have to verify the steeper for each room individually. Flowchart view of the steeper measurement, starting with the comparison between alarm signal level and ambient noise level, whether this is good enough. If not, you have to adjust the level. If it is okay, you can execute a steeper measurement or several measurements, and if the average is okay, it's above the target, then you are done for this position. If not, however, you might have to record more cycles. For instance, if you have some fluctuations of the results, if they are not very stable, maybe with executing more cycles, you come to a more stable point. If that is okay, then you can calculate the arithmetic average. If not, however, you have to take counteraction and redo the whole verification process. When we take a look at the operation of the XL2, I have shown you that in the steeper mode you can directly measure or manually enter the average ambient noise level. Then you execute the steeper test by feeding the test signal to the PA system. You can press the Pages button to watch the other screens that give you additional auxiliary information. Or you can execute several test cycles after each other and calculate the average of it, for instance, several cycles per position or per room, so that you get directly the overall result for that location. And don't forget to save the measurements. Some possible actions that may need to be taken to improve the speech intelligibility or the audibility. The most simple one, of course, is to optimize the alarm signal level. You might be forced to improve the PA system itself. As mentioned before, eliminate any hum, clipping, feedback, any disturbing behavior of the system. Maybe an equalization helps you to reduce the bass. Bass is normally having a negative impact on the speech intelligibility. Or you might even have to extend the installation by more loudspeakers, using directed loudspeakers that only have their direction to the people who are in the room, and in that way you can avoid reflections. Reflections would cause a reverberation, and the reverberation is always negative for the speech intelligibility. So here we are already at the room acoustics when we talk about reverberation or RT60 of the room. So maybe you have to install some sound absorbers to improve the situation, or you have to improve the insulation of that room towards the outside world. For instance, if the traffic noise is having a very strong and negative impact on the situation inside. Some further hints and tips, very important. Avoid any impulsive noise during the steeper measurement. People talking, traffic noise, any kind of noise will compromise the steeper result and has to be avoided under any circumstance. When we talk about maintenance, make sure that the PA system, after it has been verified and approved, is not amended or compromised by external means. Setting up a huge panel in front of the loudspeakers, for instance, will have, of course, an impact on the acoustical behavior, and that has to be avoided. But you can verify that very easily with a visual control. Then if you have to replace a component or a module in your signal path, it has to be verified that the whole system is still working fine. And then it is strongly recommended, partially even required by law that you re-evaluate the situation once per year. That can be done by a hearing test or by repeating the full or at least part of the test procedure. Well, I'm at the end of the presentation. So thanks again for your attention and have a good day. Bye-bye.